Hello friends, welcome back to another great video of Rajvi Teaches. All the videos of Rajvi Teaches are great. Okay, so let's start. So today we are going to learn a very interesting chapter, which is magnetic effects of electric current. So in this chapter we will learn the following things. First is the basic magnetism wala gyan, the basic knowledge that we should have about magnetism. Next, the Oersted experiment, the experiment done by Hans Oersted. Then, why lines do not cross each other? It is a very small topic. I hope you guys already know this, but still, I will teach it again in my way. Then, the magnetism in straight wire, magnetism in circular loop wires. Then, the hardest thing, electromagnetic induction. Then, motor and generator, and then domestic circuits. You may think that motor and generator is deleted from the topic, but it is very important. And yes, in electromagnetic induction, motor and generator comes. So sometimes I have seen in 2023 boards and 2024 the sample papers, the questions about electromagnetic induction does have some topics which is in the motor and generator. So we will study these all. We will study these also. Okay. So let's start with the first thing, basic magnetism wala gyan. So let's take it all the way over here. Here, let's first of all we will see how a magnet looks like. So in this chapter we will just study about the bar magnet. There are also the other types of magnet like the horseshoe magnet, then the circular magnet, button magnet, which we call it. But we will only learn about the bar magnet. So what happened? So let's see. Let's make a bar magnet. Okay, so bar magnet is rectangular. Let's duplicate and place it here, and let's change its color to blue, and we do not have any red, so our only option is pink. Okay. I think this blue will look better. Okay, so it is a bar magnet, and in a bar magnet there are two poles. First is north and the next is south. So let's recap those things that we have studied from our childhood. That first, like charges repel each other. I think this is the right spelling of repel. Repel, R-E-P-P repel. What is the spelling here? Repel. No, I think there is only single P. Repel each other, and the next thing is, unlike charges attract each other. Okay, so what does that mean? Let's see. I know you guys already know that, but still, what does lock? Okay, so we have made it, we have grouped it. Let's duplicate it again. Can't we? Oh no, we cannot. We have logged it. Let it be. Okay, we have to undo. Sorry. Yes. Yeah, now we can. So we will see if we put the same poles. We will put the same poles. Can we have to rotate it, and I cannot rotate it. Okay, so first is that second is that unlike charges attract each other. So south and north will attract each other, they will attach, and north and south will also attract each other. But the unlike charges, can we rotate it, please? Can we? Let's see. Okay, so let's make it like this. Okay, we just swapped it. So now we will see that like charges, south will not attract each other, it will repel, and same as it, north and north will not attract each other, they will repel. So this is the first basic magnetism wala gyan which we have studied since our childhood. Next, let's see what happens when we place a magnet. First thing, let's duplicate it again. Okay, duplicate and take it all the way over here. First, when there is a magnet, what are the things that happens? First, let's see. We place a magnet. The first thing. Uh, okay. So the first thing that we will observe is that there. Let's remember the sequence. It is very important. The sequence in which I am writing all these. It is first is there will be magnetic field. So a question comes, what is magnetic field? The magnetic field is just a field around the bar magnet in which all the magnetic field lines are present. This is the simplest definition that I can go with, that it is a field around a bar magnet in which the magnetic field lines are present. Okay, so if also in exams a question comes to draw the magnetic field and not the magnetic field lines. So many students make the mistake of drawing like this the magnetic field lines, but the actual question it is asking to draw the circular field around it. Okay, so yeah, this is a mistake, but let it be. So the magnetic field is a circular, it is virtual, means it is imaginary field around the magnet. Okay, next what comes is the magnetic field lines. Okay, so the magnetic field lines, just as I draw, just I drew I think draw ka past drew, yeah, just I drew it, the north south. So we will see that inside the magnetic field there are lines, and these lines flow from north to south outside, and from south to north, we can use this I think, yeah, and from south to north, uh, yeah, from north to south outside, and from south to north inside. Okay, so this is the property of the magnetic field lines. Next is yeah, there's only two things that happen. First is there's a magnetic field around it, and the second, the magnetic field lines are present inside the magnetic field. Then what are the properties of magnetic field lines? First, let's see the properties of magnetic field lines. Okay, properties of magnetic field lines. Okay. So dot dash, not yeah, okay. So first is that they do not inter intersect. We will come to why, but first let's just write the properties. Next property is that it is concentrated near the poles. Okay. Third is that its concentration decreases with increase in distance. Okay. Also there are many other points, but those are not coming to my mind for now. So let's go with only these 3 points. Okay. So what we studied till now, the magnet, the basic magnet, which is bar magnet, like charges north repel each other, and like charges north and south attract each other. Then we studied that when we place a magnet, two things happens. What? First, a magnetic field is generated. The magnetic field is a virtual imaginary sphere around the magnet in which the magnetic field lines are present. Okay, then we studied what are magnetic field lines. Magnetic field lines are imaginary lines that go from north to south outside and from south to north inside. Okay, they form a closed figure. Yeah, they, this is also a point. Okay, they form a closed circular loop. Okay. The properties of magnetic field lines are they do not intersect, never intersect. We will come to why. Then it is concentrated near poles. We will see that all the magnetic field lines are very much dense near the poles and are very less when as far we go from the magnet. Then its concentration decreases, so just what I said. Then it forms a closed circular loop from here to here. It is circular loop. Okay, so then let's come to the Oersted experiment. Hans or Oersted was a scientist, I think American scientist or German scientist, no one cares. So the Hans Oersted experiment was, it was actually an accident. This experiment was done in an accident. What happened was there was a wire. Let's make a thick wire. Okay, thick silver, no, not silver, let it be black, let there be thick black wire. There was a wire. Okay, and in that wire current was flowing. Let's make a circuit. Okay, circuit would be better for it. In the circuit current was flowing, and Hans Oersted was having a magnet, a basic magnet, not magnet, sorry, was having a compass, a basic compass which consists a magnetic needle. Okay, so let's make the magnet. We will choose a circle. Let's make a perfect, oh man, let's make a perfect circle. What the hell is this? Yeah. Let's make a perfect circle. Yeah, he was having a magnet. Sit यार, हमेशा खराब हो जाता है. Wait. Okay. Now it is perfect. Yes. So he was having a magnet. Okay, and in that magnet, let's draw the poles: north, south, east. Yes, it is east and west. So we see that the initial position of the compass is in north-south direction. It is red in color and it is black in color. So it is in the north-south direction, means from north to south. Okay. So but when he put that compass near the uh, wire, near the conducting wire where current was flowing, he saw a deflection, means the original position was it, but he saw that the compass needle move from north south to here to another position, and this proved that the current carrying wire produces magnetic field. And then this caused us to study this city chapter, magnetic field of magnetic effects of electric current. Okay, so this is only the worsted experiment. Now let's see. Next, it is a small topic. Why do the lines do not cross each other? Let's see this here. If you see here, we see that the lines are not parallel because it's my merge. The fuck, what I am doing? I'm very cringe. Sorry, let it be. So we see here. कहाँ गया? हाँ. Why do the lines do not cross each other? It is because we know that in a magnetic field lines, the magnetic field lines, let's it be a magnet. Uh, okay, so in the magnetic field lines, in any point on the magnetic field line, let's check this point. Okay, a tangent is drawn sorry, no, this is not a tangent. Yeah, a tangent is drawn. Let's draw a tangent, and the tangent tells the direction of force. Okay, in any part of the magnetic field lines, magnetic field lines, a tangent is drawn, and that tangent shows us the direction of force. But if we see, if two magnetic field lines intersect each other, okay, let it be two magnetic field lines A, B. If these two intersect each other, so we see at the point of intersection we can draw two tangent. Let's take another color for it. We can see two tangent, means two direction of force. But two direction of force is not possible. This is not possible because direction of force cannot be two different points, two different in a single point. Okay, so that's why magnetic field lines do not ever intersect each other. Sorry, this will be south, north, yeah. And this is the reason why magnetic field lines do not intersect each other. Then we will come to the main things, the main core of the chapter. First is magnetism in straight wire, second is magnetism in loop wire. Let's go this, let's take this to here. Okay, first in straight, fuck it, I will write in a in with a text. Okay, in straight wire, boom, yeah. So in straight wire we will see, let's draw a straight wire first. This is a straight wire. Okay, so in a straight wire the magnetic field is known by the direction of magnetic field is known by the thumb rule. What does the thumb rule say? Take our right hand thumb and put it in the direction of current. Let us assume that the current is flowing like this. So we will take our right hand thumb. This is our right hand, pinky finger, yeah. This is our right hand. We will take our right hand thumb and place it in the direction of current. So here the fingers, we will see that the fingers are going this way, the tip of the fingers are going this way. So the curve that our fingers make, that is the curve which tells the magnetic field around it. So in this case the magnetic fields will go like this, in a circular way. Okay, so also there is also an experiment for in exam question comes, so as an experiment which proves that in a straight wire current, in a straight wire carrying current, the magnetic field lines are in circular shape around the wire. So we can show it by the following experiment. First we will take a cardboard. This is a cardboard. uh, I know this do not look like a cardboard, but we have to assume it as a cardboard, and if not, then fuck off. Yeah. So sorry. So in this we will take first um a cardboard, and on that cardboard we will draw, let's take the color purple to draw the wire. This is a wire which is pierced through the cardboard. Okay, oh yeah, a wire is pierced, r par in Hindi. Okay, so if we will place iron fillings, you know what iron fillings is? Iron का चूरन, वो जब इंडस्ट्रियल जगह पे, in the industrial places, when iron is cut, some pieces, some threads of iron are left, and those are iron fillings. And if we put that here and shake it off a little bit, we will see that it will produce a pattern. Okay, and this proves that in a current carrying straight wire, the magnetic fields are in the circular loop around the wire. And if we have to see the direction of current, we will place our right hand thumb. This is our right hand thumb, and these are all the other fingers. Man, okay. So we will see that this is the direction of current, and our fingers are making a curve in this way. Okay, in this way. Sorry, it will make a curve in this way. So we will know that the current is flowing like this. Swing. This is the direction of current. Now, where's the eraser? Let it be. I will not erase it. Okay. So this is in straight wire. Now, second, two. In कौन बच्चा चला रहा था? Let it be. In there is the text circular wire. Oh yeah. Sorry for the noise that is coming from outside. The children are sick. Crap, people. Circular wire. Also, do not mind my English. I know it is very bad, but still, just trying because I want to speak English very fluently. Okay, wait. Times. Let me close the window. Back. Okay, so now we are seeing in circular wire. In a circular wire, let's make a circular wire with the color purple because fuck. So it is a wire, circular wire where current is flowing. And if you will question, Rajveer, there is no battery, how the current will flow? So fuck off, here's a battery. Happy? So we see that in a wire which carries current in a circular motion, the magnetic fields occurs as what we say this straight. Yes, it comes straight. And how straight? It goes around the wire in a straight motion. Okay. uh, yes, it goes around the wire in a straight motion, like this here, and also this side, down, up. Yeah, it goes like this. And how we will understand how it goes? There's also another rule which is screw. I cannot pronounce it. Screw. Yes, screw rule. SCREW. Screw the nut bolt wala screw. Screw rule. Okay. Boom. The screw rule. And what does the screw rule speaks? Everyone has seen a screw. It is like this, a nut bolt. Okay, so in a circular wire like this, we will place a screw here. Okay, let there be a screw, and we will see. We will rotate the screw in the direction of the current. Imagine the current is flowing like this. Okay, so we will rotate the screw like this, and everyone knows when screw is rotated inside like this in what we call clockwise. Yes, when screw is rotated clockwise, the screw goes inside. Okay, and when it is rotated anti-clockwise, it goes outside. So we see in a current carrying wire, if the current is flowing clockwise in the circular loop, then the magnetic field be inside. it will be inside. Okay, it will go inside. And just opposite to the case, if the current is flowing in outside, we will see, sorry, not outside, if the current is flowing in anti-clockwise direction, then we will place a screw just here and rotate it in anti-clock. Oh man, this is still clockwise, sorry, my bad. Yeah, pen, it, if it is going in anti-clockwise direction, we will move the screw anti-clockwise. And everyone knows, if you do not know, then it is your mistake. Everyone knows that if screw is going anti-clockwise, then it comes out. If it is going clockwise, it gets inside. Okay, so this is the rule that we will use to tell the current flowing in a circular wire. Now, the sit I have done here, man. Let it be. Okay, it is good. It is good sit. Now, the core of the chapter, electromagnetic induction. Yes, you heard right. Electromagnetic induction. So, what the hell is this sit? Let's see. Wait, let me come from the washroom, then I will continue. Let me tell you a secret now. I know no one will be watching till now because the fuck I do not know. Okay, so the secret is that the reason why I am so franky in this video is that my parents are not home और कोई काम नहीं करने को और हमको आई इंग्लिश इंग्लिश या एंड आई डिडेंट सेम ही चीज़ था आई डिडेंट वो फक यार क्या बोलते हैं हमको भी पढ़ने का मन नहीं कर रहा था तो पढ़ाई नहीं करने से अच्छा बहाना है कि पढ़ाओ सो लेट्स कंटिन्यू आई एम बैक आई विल प्ले द वीडियो फ्रॉम हियर and this part will be cut. Now we are going to Fuck. Now we are going to study electromagnetic induction, the hardest part of the chapter. So first we will study the definition. We will take electromagnetic induction just here. So we will see. Let's zoom. So we see. First of all, let's go through the definition. I know you will not understand the definition, but still, uh, I will explain it later. But let's write the definition first. It is the phenomenon in which, okay, in which current is. We will not write current. We will write voltage. And what is the better way of writing voltage? EMF, electromotive force. It is a phenomenon in which electromotive, how yeah, electromotive force. Let's see. Electromotive force is produced when a a magnet is क्या कहेंगे मूव्ड कहेंगे ना हाँ इज डिस्प्लेस्ड कह सकते हैं हाँ डिस्प्लेस्ड हाँ डिस्प्लेस्ड नियर a conducting wire wire, when a magnet is displaced near a conducting wire with respect to time. Okay, so let's understand what this crappy thing I just wrote. Yeah. So imagine there is a wire, and what is the color of wire? Purple. Yeah. So imagine there's a purple wire. Okay. And near that there's no current flowing through it. Okay. So in the purple wire no current is flown. Let's make it circular because circle is the better way to visualize things. So imagine there's a circular wire where no current is flowing. It is in loop where no current is flowing. Okay. So in this, where is black? Yeah. In this, if a magnet, let's imagine it is a magnet. Okay. In this, if a magnet is going in and out, means it is displaced from one position to another. Okay, it is displaced from one position to another and then come back, means it should be moving. If it is moved with respect to time, means with respect means टाइम जा रहा है और वो मूव हो रहा है एक पोजीशन दूसरे पोजीशन में, ठीक है ना. If it is moving with respect to time, then current will be produced inside in the circular wire, and this is the what for, sorry I forgot. Yes, and this is electromagnetic induction. Cut that part also. Okay. So what we just, let's recap it. um, it is that in a circular wire, okay, in a circular wire, in a circular conducting wire, if a magnet is moved, displaced from one position to another with respect to time, okay ना, time के साथ move होना चाहिए, then current will be produced which is electromotive force और voltage will be produced in the wire. और इसमें भी हम लोग को ये पता करना होता है कि what is the direction of current. Okay, so this is called Faraday's law. क्या कहते हैं इसको? Where is the text? Yeah, text man. Faraday's law. Yeah. What is Faraday's law? Faraday's law क्या कहते हैं कि अगर, कहाँ गया मेरा पेन, पेन कहाँ गया मेरा, हाँ मेरा. अगर फराडेज लॉ ये कहता है कि अगर वायर जो पर्पल कलर का होता है, ऑब्वियसली पर्पल के अलावा कोई कलर का वायर नहीं होता, हमेशा याद रखना. एक वायर जो पर्पल कलर का है उसमें अगर ब्लैक कलर का मैग्नेट मूव कराए ऊपर, अपवर्ड्स, ठीक है ना, तो इसमें भी हम लोग लगाएंगे स्क्रू रूल. स्क्रू रूल कैसे लगाएंगे? अब देखो कि अगर मैग्नेट ऊपर मूव कर रहा है तो इमेजिन करो कि करंट फ्लो हो रहा है, ठीक है ना. अगर करंट फ्लो हो रहा है तो किस डायरेक्शन में करंट फ्लो होना चाहिए कि मैग्नेटिक फील्ड अपवर्ड्स हो. तो हम लोग अगर याद करेंगे जो हम अभी जस्ट पढ़ाए 2 मिनट पहले, 2 मिनट नहीं उससे ज़्यादा ही हो गया होगा, जब हम जस्ट पढ़ाए स्क्रू रूल, स्क्रू रूल. ओके, ड्रामेटाइज कर रहे हैं स्क्रू रूल. यस, तो स्क्रू रूल के हिसाब से हम लोग पढ़े कि अगर हम लोग, क्या पढ़े भाई, रुक जाओ एक सेकंड, सॉरी, हम लोग जैसे जा रहा है, हाँ, अगर हम लोग करंट को एंटी क्लॉकवाइज डायरेक्शन, मतलब हाँ, अगर करंट, अगर स्क्रू एंटी क्लॉकवाइज डायरेक्शन में मूव करता है तो जो मैग्नेटिक फील्ड होते हैं बाहर आते हैं. मतलब अगर यहाँ पे एक वो है, क्या कहते हैं इसको, वायर है, उसमें करंट जा रहा है ऐसे ऐसे, तो एंटी क्लॉकवाइज डायरेक्शन जा रहा है, जिससे जो करंट प्रोड्यूस होगा वो कैसे होगा, बाहर, ठीक है ना. तो इसमें बाहर हो रहा है तो इसमें करंट कैसे फ्लो होना चाहिए? करंट इसमें ऐसे फ्लो होना चाहिए कि वो मतलब क्या कहते हैं, ऐसे, जो भी है बस ऐसे होना चाहिए, ठीक है. इसमें करंट होना चाहिए ऐसे. और इसी का अपोजिट अगर, मैं अंडू अंडू अगर एक वायर है जिसमें अगर हम लोग मैग्नेट को मूव कराए ऐसे इनवर्ड्स, जब ऊपर किए तो हम लोग का करंट ऐसे प्रोड्यूस हुआ, और जब इन वो बाहर किए ऐसे तो हम लोग का प्रोड्यूस ऐसे करंट ऐसे प्रोड्यूस होगा कि जो ये है इसी का उल्टा स्क्रू जब ऐसे घूमता है, जब ऐसे घूमता है तो ये अंदर जाता है ना, तो इसमें क्या होना चाहिए, ये अंदर जा रहा है तो हम लोग का स्क्रू क्लॉकवाइज घूमेगा, क्लॉकवाइज मतलब ऐसे, बस यही है इलेक्ट्रोमैग्नेटिक इंडक्शन। इंग्लिश बोल रहे थे नरे कच्चे वाले। ओके, आई विल अगेन नाउ फ्रॉम नाउ कंटिन्यू टू स्पीक इन इंग्लिश। So now let's see another topic, which is motor and generator, which is totally linked with electromagnetic induction. For motor and generator, I have to open my copy because I am also human. I do not know everything. So first, see a generator. First, let's see both together. Okay, let's take it. Where should we take it? I think this should be taken all the way to down, downwards. Yeah, this is a good spot. Yes. So in if what is motor and what is generator? Motor and generator are just wires. What type of wires? Um, Rectangular wires. Okay, rectangular wires. You have seen in your fan or inside motors that there is a coil, copper coil, which is coiled like this, है ना, in a something it is coiled like this. Okay, so what does it say? Let's see. Wait, here is one. So it is magnetic wire, and in that magnetic wire, fuck it, हमको भी नहीं आते टॉपिक, ज़्यादा गाली दे दी है, सॉरी, इसको भी कट करना होगा। चलो लेट्स सी डोमेस्टिक सर्किट्स, बिकॉज इस टॉपिक को काट, बैक 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 बैक, यस, ये टॉपिक को कट कर दो क्योंकि वो, लेट्स कट दिस टॉपिक बिकॉज दिस इज ऑल्सो मेरे औकात के बाहर। देयर वॉज नथिंग रिटन हेयर लाइक मैग्नेटिक जो भी है, मैग्नेट्स, मोटर्स एंड जनरेटर्स, फक व्हाट हैपेंस। ओके, let's learn domestic circuits, guys. Domestic circuits is a very good topic, man, very good topic. Okay, it is the best topic actually. Let's open the book for my reference. Where's the book? Here it is. I just hope ये पागलपंती कोई देखे नहीं भाई, नहीं तो एक्सपोज हो जाएगा हम सबके सामने। Okay, here it is. Yeah, I now see it. अब you may think, राजवीर तो फ्लेमिंग का लेफ्ट हैंड रूल तो बताया ही नहीं, वो कब बताएगा? तो वो भी बता देते क्योंकि अभी हम बुक खोले तो हमको वो अभी दिखा, सॉरी। तो फ्लेमिंग का लेफ्ट हैंड रूल क्या कहता है? फ्लेमिंग का लेफ्ट हैंड रूल हम लोग कर लेते हैं यहाँ पे, ठीक है ना। लेट्स फर्स्ट लर्न फ्लेमिंग्स लेफ्ट हैंड रूल। FLEME, FLE आ गया भाई, spelling FLEMING, sorry, FLEMING, Fleming's लेफ्ट हैंड रूल। ओके, ये दोनों जो है ना वो एक्चुअली जनरेटर मोटर के लिए यूज होता है, लेकिन कुछ पार्ट इसका डाल दिया है हम लोग का सिलेबस में। तो इसको स्टडी करने का एक बहुत ही सिंपल तरीका है, जो डर्टी तरीका है, जो तरीका हम अपनाते हैं, टॉपर्स ट्रिक, ठीक है ना। हम लोग को पता है इसमें क्या कहता है, पहले ये देख लेते हैं। एक अपने लेफ्ट हैंड का 3 उंगली, इंडेक्स फिंगर, मिडिल फिंगर एंड थंब का हम लोग यूज करते हैं और प्लेस कर लेते हैं एक्स वाई जेड एक्सिस में, ताकि वो बनाए ऐसे टाइप से। ये है हम लोग का थंब, ठीक है, इसको हम थंब मान लेते हैं, हम लोग यहाँ पे बनाते हैं इसको, हम लोग का थंब है, ठीक है ना। हम लोग का ये इंडेक्स फिंगर और ये हम लोग का मिडिल फिंगर और बाकी उंगली, sorry for the bad drawing but I cannot do anything. So thumb, index finger, middle finger. So what this tell is that the thumb says force. Okay, what the thumb says, the thumb tells us about the force. Then the field, the magnetic, the current, the magnetic field, sorry, the magnetic field, the index finger tells about the magnetic field, and the middle finger tells about the current. Current is denoted by I We can also write it like C, current. Okay, so the dirty trick that I use is that giving this an acronym, and that acronym is fuck mother chod. Fuck mother chod. Fuck mother chod. I hope no one sees it, man. बहुत गंदा फंसेगा. Okay, so it is FMC, fuck mother chod. Force magnetic field current. So this is the trick that I use for uh, my exams, or what we can say, the trick produced by me. So it is the it is not some the fuck I start क्या कहते हैं ब्ला ब्ला पे करने लगते हैं जब वो होते हैं नहीं. Okay, so what it tells is that what I am telling is, what I was saying is that it is not something that is a difficult topic. It is actually very easy, and the only use of it is that in exam some question comes about which tells that what we say, some positively charged alpha particle उस डायरेक्शन में जा रहा है, मैग्नेटिक फील्ड उस डायरेक्शन में जा रहा है, हम लोग को फोर्स का डायरेक्शन बताना है. तो वो सब बहुत इजी होता है. इसमें बस ट्रिक क्या होता है ये बता रहे हैं. इसमें बस एक ट्रिक होता है जो यूज करते हैं, द डर्टी ट्रिक विच द एग्जामिनर्स और द क्वेश्चन पेपर जो बनाते हैं वो लोग यूज करते हैं. एंड व्हाट दैट ट्रिक इज दैट what they do is tells us the direction of electron. Okay, we all know that the direction of electron is opposite to the direction of current. The current flows opposite to the direction of electron. Okay now, so what would the examiners or the question paper makers do is that they tells us about an electron is moving towards north. Okay, and a magnetic field is produced, not magnetic, and it is deflected towards east due to some force. Okay, and हम लोग को magnetic field का direction बताना होता है. So what the normal mistake done by the normal students is that they think that the direction of current is the direction of electron, and they do that it is in this way, and then what they get is that we apply this, and then we place our middle finger in that direction. Okay, then it is deflected towards this. So let it make right start. We will please fuck फिर blah blah करने लगे. Okay, so what we do is we place our middle finger in the direction of electron, then we place our index finger in the direction, not index, sorry, we place our thumb in the direction of force because it is deflected, and so we get that the magnetic field is upwards, but that is totally wrong because the direction of electron is not the direction of current. What we have to do, if the electron is flowing that way, then the current is this way, just the opposite. Okay, so what we have to do, we have to place our middle finger, that is I see, to opposite of the electron. Okay, and then if we do, we get that the magnetic field is downwards, and this is right. So this is a common mistake done by everyone. So the only thing about Fleming's left hand rule is this, please avoid it. It is a very silly and huge mistake. Then we come to my favorite topic, which is domestic circuit. And let's take domestic circuit to the spot in which motor and generator was. So domestic circuit is also a very easy topic. The only major important thing in it is about the colors of wire, about the fuse, and overloading. बस तीन चीज. Okay, so what we have in domestic circuit, color of wires. Let's try the American accent. Okay, so what we have in domestic circuit, we have the first is that we have color of wires, then second we have to tell about the fuse, and the third is what is overloading and how does it happen. Overloading, ing, loading. Okay, so these are the three things that are in what we say, in domestic circuits. Okay, so first of all, let's see color of wires. So the color of wires are, let's take it here. You may have seen in sockets. Let's make a socket here. This is a socket. Okay, so you may have seen there are three pins. First is this. Let's make it green. Okay, first is this. The second is, okay, oh yeah, set. Okay. The first is this. The second is a square type of. Here, let's take this color as red. Unfortunately, there is no red, so we will take pink. And the third here, which is black. We will take this as black. Okay. So the what does the three pins in the socket tells? So this is the main question of domestic sockets. Okay. The first is the green one. It is earthing. Earth wire. What is the use of earth wire? The main use of earth fire is that when there is an excess current, okay, so it absorbs all the current and takes it to the earth. Okay, this is earth wire. It is green in color. Oh man, oh, green. Then this is not pink, actually it is red. It is live wire, live, through which the main current comes. Okay, live wire. It is red in color. And this one, it is neutral, and it is black in color, black. So what we let's do something is that identify it like this. Okay, this is better. This is live wire, then this is neutral wire, and green, let's take green, and this is earth wire. So in exam sometimes question comes in which we have to draw the domestic circuit. So many people draw the figure which is given in book, but that is very hard and not necessary. We can draw a simplified figure. For that is just one wire which is live. Okay, then we can draw what is a bulb. Let bulb, bulb. Okay, this is a bulb, and we will draw the wire which takes back. It is neutral. Then we will take here like this and earthing. This is a symbol of earthing. Okay. Oh man, sorry, I think I should draw better. Actually it is not my mistake. The problem is that I am doing all of this with mouse. Okay, so this is earth. So main question is, the main things we have to know about it is that neutral wire have zero voltage, earth have zero voltage unless there is overloading, and the live wire have voltage, well, normally 220 volts. Okay, these are the important things. Then we now we study overloading. Okay, we saw the color of wires. Now let's see. First we see fuse. Okay, what is a fuse? Fuse is just fuse is a device. We can define fuse as a device which is made up of very thin wire. Okay, and what is the purpose of fuse? It prevents us from short circuit. How it does that? Imagine there's a fuse between your house. This is your house. Okay, and this is the supply. So imagine if excess current is coming to your house, and your house have this bulb, and the rating of this bulb is that it can only handle 5 ampere. Okay, अगर इसको 5 ampere से ज़्यादा मिलेगा, then it will be short. Okay, it will overload and have a short circuit. So if excess current is coming more than 5 ampere, then what will the fuse do? That it will melt. Okay, it will melt, and thus it will break the connection. How it will break it will melt and stop the connection. Okay, it will stop the connection, and then the excess voltage could not reach your house, and this prevents overloading, short circuit. Okay, Basically, what is fuse? It is a device which prevents short circuit in our house by melting. Okay, so major points to remember is oh बात करें क्या? Okay, stop, pause.